So this section is about inverse functions. So when we have a function, it can also have an inverse. Not all functions have inverses, but we're going to talk a little bit about what that all means. So the main idea for inverse functions is you have something, you're doing something, and then you're going to undo it. So it's kind of like if you live at your house, and you want to go to the store, and maybe you go out here and you turn, let's see, well, if you're facing forward, you turn left, and go up here, and then you turn right, and you get to the store. There's the store, okay? The inverse would be coming home from the store. So you'd go out here this way, maybe west, and then go south, and then go west again, okay? Whereas the first time to get to the store, you were going east, and then north, and then east, right? Okay, so this is this idea that you get back to where you started from. So that's how inverse functions work. They give an example in the book with a formula. Now this is the formula, that should be a capital C. It's converting from, pretty sure it's capital C, yeah, Fahrenheit to Celsius. So say you have, say it's 70 degrees out Fahrenheit, and you want to figure out what that is Celsius. Well, you can put the 70 in, right? Okay, so you would have C equals 5/9 times 70 minus 32. This is not the example in the book. And then you could work that out, get a calculator, and you'd come up with a number. Let's see, I don't know what it's going to be. It's going to be around 20 something. Okay, so I took the time to figure it out on a calculator, but it's like, it's approximately 21 degrees Celsius, okay? But now let's say you want to go from Celsius to Fahrenheit. Well, when you do that, look at this formula we have here. You would say if C equals 5/9 times Fahrenheit minus 32, then you could put in the 21, and it's not going to come out exact because I rounded off, but then you would be solving for F. So you'd have to do the opposite calculations from what you were doing to get to Celsius. Okay, you'd have to multiply by 9/5, and then you'd have to add the 32, and then you'd get, approximately 70 degrees. It'd be close. Okay, but that's this idea. We'll show you in detail how to do these things, but that's the idea of inverses. Okay, move this up. Notation. So there's specific notation that goes with an inverse. A function could be called f of x, but the inverse of that function would be, we say f inverse of x. Okay, so then these two are inverses by notation. Okay, so we don't have a function here, but that's what the notation looks like. So if you had g of x, for a function, its inverse would be represented by g inverse of x. And that's how it's read, g inverse of x. That is not a negative exponent. It is inverse notation. I know it looks like a negative exponent, but this is inverse notation. Okay? So, normally if we have something like, y to the negative first power, we know that equals 1 over y. That's a different thing. That's true. That's a negative exponent. But that's not what this -1 means, okay? This is a negative exponent. And we've worked with those in the past. But this is inverse notation. And it's inverse notation because it's on the name of a function, okay? Now, if you really wanted to take your function to the power of -1, you could do that. You could write it like g of x, and then raise that whole thing to the -1 part. But let's not get too complicated here. Okay, so the rules. First of all, in order for a function to have an inverse, it has to be 1-to-1. Okay, so if it's not a 1-to-1 function, it doesn't have an inverse. Now, you can restrict things to get a function to be 1-to-1 sometimes. Sometimes you can't. So just keep that in mind as we later on talk about that. And then two things have to happen. If you take a function and you compose it with the inverse, and remember that can be written as f of f inverse of x, like that, that has to equal x. And then it also has to work the other way. If you take f inverse, compose f, because remember order matters when we're doing composition. So if I take f inverse of f of x, that also has to equal x. So in order for two functions to be inverses, these two rules have to apply, okay? And it has to be a one-to-one function, okay? Just lastly, inverses have to work for all of the domain, and not all functions have inverses. Okay, so just keep those things in mind, but we'll explain it more as we go through the videos.